Hi and welcome back to CSEC Integrated Science. So last class would have been a physical class in school. So as I know that some of you all weren't there, I am going to go through the examples that I did and I will post this video so you can look at it. So you already have the note and these are just the examples that I went through. So we looked at example 1 and example 2 on page 123 of the Collins Concise Revision course. So the first example is very straightforward. So it's just learning how to apply the formula. So in order for us to get the unit of momentum, we will multiply the units of each of the different parameters. So momentum is P equal to the mass multiplied by the velocity of your object or your body that is in motion. So from here, we would have seen that mass is given as 0.25 kilograms and velocity is given as 300 meters per second. Now, momentum is a vector quantity, so direction is very important. Now, because we are only looking at one moving body, we would not have to consider any directions. Everything is going to be positive, all right? So it's 0.25 kilograms multiplied by 300 meters per second to give us 75 kilograms meters per second. Because the unit of mass is kilograms and the unit of velocity is meters per second. So you can write your units for momentum like that, or if you want, we can write it as kilograms meters per second. Both ways are the same. You do need to pay attention to the units of your individual quantities, as that would affect the units that you are stating for momentum. But the SI unit of momentum is this, which is kilograms meters per second. If your mass was in grams, then you would have gotten momentum being grams meters per second. Now that is not incorrect, but that is not the SI unit, right? So SI units, we are using standard units. Standard unit of mass is kilograms and the standard unit for velocity is meters per second. So that's example 1. Example 2 involves a little bit more work. So what we will be doing now, I will go across on the side and I'm going to explain it slightly different to how the textbook did it. So the question is given in example 2. So we have car A of mass 1,000 kilograms moves east at 20 meters per second, and car B of mass 1,200 kilograms moves west at the same speed. What is their total momentum? So in order to get the total momentum, we would need to find the momentum of vehicle A and add it to the momentum of vehicle B. But remember that momentum is a vector quantity, and because it's a vector quantity, direction is important. So we will be looking at linear momentum, so we will only have two directions, left and right, or in this case they are using east and west. All right, so if you look at it on a cardinal, then up is north, down is south, to the right is east, and to the left is west. All right, so the car moving to the east, we are going to assign it the positive values, and the vehicle that is moving to the west or to the left is going to be associated with a negative value, right? And all the negative sign indicates is the direction, right? So since the cars move in opposite directions, we can designate east as positive and west as negative. There is nothing wrong if you flip it around and designate east as negative and west as positive. Overall, you will end up with the same value at the end. So we were going to look at this in a little bit more detail. So back on this side, I am using a ball to represent vehicle A. So this is vehicle A, it's 1,000 kilograms and it's heading east at 20 meters per second. vehicle B is 1200 kilograms and it's heading west. I am putting that as negative 20 meters per second. Why negative? Because it is opposite my direction that is positive. So anything heading to the west is going to have a negative value, and anything heading to the right is going to be a positive value. So total momentum is really the net momentum when I add the two of them together. So let us look at the momentum of A. So momentum again is P is equal to M by V. So the momentum of A is going to be P subscript A, which is my momentum of A. So the mass of A is going to be 1,000 multiplied by my velocity that A is traveling at. So that is why I got 1,000 multiplied by 20 to give me 20,000 kilograms meters per second. The second one now, if we look at the momentum of B, so P subscript B, I'll need to multiply the mass of B, which is 1200 kilograms, by the speed or the velocity at which vehicle B is moving, and which that will be minus 20. So 1200 by negative 20 is going to give me negative 24,000 kilograms meters per second. The total momentum is going to be the momentum of A plus the momentum of B, which is 20,000 kilograms meters per second plus negative 24,000 kilograms meters per second. A positive multiplied by a negative is going to be an overall negative value. So that's the same as saying 20,000 minus 24,000, which will leave me with negative 4,000 kilograms meters per second. That's my total momentum or my net momentum. Now remember, in the beginning, they never told us that the car was moving at a negative speed, because you cannot move at less than 0, right? The car was moving at 20 meters per second. So this negative sign, all it tells me is the direction. So if we go back now to the beginning, you would have seen east was positive. So if I had a positive value, then that would mean the vehicle is moving towards the east, or the total momentum is positive. And if it's negative, as in this case, it means that it is towards the west. So we have negative 4,000 kilograms meters per second, which is going to be 4,000 kilograms meters per second towards the west. Next, we would have looked at the conservation of momentum, and we would have listed the definition for the principle of conservation of momentum. So we had begun looking at this example, but we did not finish it. So I will continue with this in our next session.